The digital world as we know it today is constructed on the foundational work of a few extraordinary minds. These pioneers of computing not only crafted the tools that lead to the first computers, but also laid down the principles that underpin modern software engineering and digital technology. Their stories are not just tales of innovation, but are essential chapters in the history of human capability and creativity. Each stride they took was a giant leap for technology, propelling us into a future they could only imagine. Charles Babbage, Ada Lovelace, Alan Turing, Katherine Johnson and Steve Jobs. Each of these individuals brought a unique vision and unparalleled dedication to their work. Their contributions have transcended their own time, impacting our daily lives in ways that are both profound and pervasive. From the simplest calculator app on a smartphone to the most complex artificial intelligence algorithms, the fingerprints of these pioneers are embedded deeply in the fabric of our digital experiences. Their achievements are not just technical, but also cultural, reshaping how we interact with the world and with each other. The internet, smartphones, space travel, and even our understanding of human rights and equality have all been influenced by their work. It's crucial to recognize that these advancements were not inevitable, but were the result of hard-won battles by these brilliant minds. They faced personal and professional challenges, yet their perseverance and vision changed the world. Understanding the lives and works of these pioneers is essential not only for those aspiring to enter the field of technology, but also for anyone who wishes to appreciate the full scope of how fundamental concepts in computing have sculpted the contemporary world. They were not mere inventors, they were architects of the future, and this narrative is a homage to their indelible contributions. Charles Babbage, a name synonymous with the inception of computing, embarked on the formidable task of designing the difference engine and later the more complex analytical engine in the 19th century. These were not mere mechanical curiosities. The difference engine could compute several sets of numbers and make hard copies of the results, an innovation that foreshadows today's printers. The analytical engine, however, was a leap towards the future, envisioning a machine that could be programmed with punch cards, an early echo of binary code operations in modern computers. Babbage's work laid the groundwork for the binary system that underpins all modern digital computers. Imagine a world where every piece of digital technology operates on a simple system of zeros and ones. This binary system, a core component of all computer programming and operations today, traces back to the logical structure proposed by Babbage. Every smartphone, computer and digital device we use today owes a part of its functionality to his early theoretical work. Moreover, his idea of a programmable machine has permeated through to modern computing in ways that are fundamental, yet largely invisible. The software that runs our most used devices, whether it be a laptop or a large supercomputer, relies on the principles first imagined by Babbage. His vision of machine programming laid the conceptual groundwork for what would become software engineering, a field that now shapes virtually every aspect of technology and digital interaction. Babbage's foresight and innovations remind us of the power of theoretical groundwork and visionary thinking in technology. His contributions are not confined to history books, but continue to be relevant and influential in the context of modern technology. Every time we use a computer, we are essentially navigating a landscape partially envisioned by Charles Babbage. Ada Lovelace, often celebrated as the first computer programmer, collaborated closely with Charles Babbage during the mid-1800s. Her most notable work was an algorithm intended for implementation on Babbage's analytical engine. Lovelace's algorithm was designed to calculate Bernoulli numbers, showcasing not only her understanding of mathematics, but also her foresight in machine capabilities. This marked the beginning of what would eventually evolve into computer programming. Lovelace's insights suggested that a machine could do more than mere calculation. It could create music, graphics, and solve any problem that could be symbolically represented. Her vision of a poetical science where mathematics would meet the arts directly informs today's digital media.